Hello there, welcome to question 9 of our physics exam preparation series. In this question, the topic is electrodynamics and we are dealing with a DC generator. Right, so let us look at the first 3 questions as well as the context. Here you go. Okay, the first question we are asked to just indicate what is that component that ensures that current flows in one direction, and we know that is the split ring. Good. In 9.1.2, using the right hand rule, you'll see that current is towards you or coming out of the page, so it is definitely from Y to X. Okay. Right, so for 9.1.3, we're going to use the time-frequency relationship. This is the equation to help us find the time that is required there. So we've got 20 hertz, we just substitute there, and we see that it will be 0.05 seconds to complete one revolution. Okay, so let us now go to 9.1.4. Right, so 9.1.4, we asked to sketch a graph that indicates the revolution we spoke about in this previous question. So we know that it will happen in 0.05 seconds. That is the case, and halfway through, that is 0.025 seconds. That's where the current will peak, or the voltage will peak, and then we have a minimum there. And the minimum will go to the maximum again, and we reach a minimum there as well. Okay, so obviously that is where we have a voltage of 0. So this takes care of the graph that is required. I need to emphasize that the graph must have labels, so your axis must have labels as well as the corresponding SI units, right, to ensure that you get the full marks there. Good stuff. So let us go to question 9.2. Right, so the last question is about doing some calculations involving resistance, time taken, as well as the root mean square voltage supplied by the wall socket, right? So there is an equation to talk about the average energy dissipated by the kettle here as our electrical appliance, and this is the expression here. We take the root mean square voltage, we square that, we multiply it by the time taken as well as division by the resistance, and this gives us 181,500 joules. Okay, so that was pretty much a straightforward question, and it involves just direct application of the correct equation there. Good. So this takes care of question 9, electrodynamics. And we're now moving on to the last question of the paper, question 10. And I definitely hope to see you there. Right, so keep well, keep working, and achieve those excellent results. See you in the next segment. Shap shap.